All right, here we go. Tomorrow I get a full work day. I try to build those in because I know that you guys need time this year. I know that on Friday you're going to be gone, a lot of you, right? So we'll figure out something good to do with those of you who are still around. But today is not... Yes. Well, we'll learn. We'll practice. We'll do something, but we're not going to... we're not going to do a whole new lesson. So... Anyway, all right, here we go. Anybody want to guess what the integral is? Today we want to work on integration. The other day, very good. Now, your book and other books and notation often uses... instead of the variable x, uses the variable u. Why do you think they use the variable u? That's a good guess. It's not quite right. No, more than personal preference. Boys and girls, when do you use u in these problems? When you use substitution, right? Substitution, when you're doing integration, chain rule when you do the derivative. And so, 90% of the time when you're doing these problems, you do use the variable u. You substitute it in because you're doing a substitution problem. So that's why we use u. E to the u plus c is your antiderivative. The integral of, we'll try this, natural log of u. Whoop, nope, we don't know that one yet. Integral of 1 over u, the antiderivative of 1 over u du is equal to natural log of u plus some constant. And then we want to do one more. We want to do an exponential. The integral of b to the x dx is equal to, make sure I get this, b to the x over natural log of b plus a constant c. So those are the three main integrals that we're going to be using today. They are on your various calculus notes worksheet, a sheet of notes that I've given to you. So we can do that. So we want to just, you know how to do all this stuff. We just want to familiarize your eyes with what you're going to see. Okay, that's what we want to do. Okay. Oh shoot, I gave you bogus problem right off the bat. Change it to a 2. So, you've never been able to do this antiderivative before, have you? Well, that's a good question. Why not? Why haven't you been able to do the integral of 2 over x minus 2 before? X is to what power? Yeah, or the negative 1 is it's in the denominator. And we haven't been able to take the antiderivative of x to negative 1 until now. You know that the integral of 1 over u is equal to natural log of u plus c. So watch my substitution here, okay? I'm going to make a substitution. U is equal to x minus 2. So du is equal to, what's the derivative of x minus 2? 1. So just dx. You have a dx and you have a 2. So I multiply both sides by 2. So you have 2 du is equal to 2 dx. So I now have this integral. The integral, I'm going to put the 2 out front, from 3 to 8, of 1 over what? U du. What is the integral of 1 over u? Natural log. And I'll plug u back in. U is what? Yep, x minus 2. And we're going to do 2 times that, and we're going to evaluate it from 3 to 8. So let's plug them in. When you plug in 8, you get 2 times the natural log of minus 2 times the natural log of 1. Do you remember what you can do with natural logs if you have a constant out front? Bring it to the exponent. So you have the natural log of 36 minus the natural log of, what's 1 squared? 1. And do you remember when you have subtraction of 2 natural logs, you can write as division, so the natural log of 36 over 1, which is simply natural log of 36. That's your answer. So a lot of people can get to this point, 2 natural log of 6 minus 2 natural log of 1, and then they're like, how did the book get natural log of 36? Well, it used your rule of logarithms. That's why we did that review last week. So I'm hoping that was helpful. Okay. Any questions? Not too bad, huh? All right, let's try the next one. Ooh, e to the x over e to the x minus 1. No, because it's a definite integral. If it was indefinite, then we would need a plus c. Anybody want to guess what u should be? What is du? dx. Do you have an e to the x dx? You do, so you can make the straight up integration, or substitution. What is my new integral? 1 over u du. What is the antiderivative of 1 over u? So we're going to have natural log of u, which is, what is u? E to the x minus 1, evaluated from 2 to 4. We get the natural log of e to the 4th minus 1 minus natural log of e to the squared minus 1. Can you do anything about the subtraction on the inside? No, you can't. Can you do something about the subtraction here? Put them over each other. Natural log of e to the 4th minus 1 over e squared minus 1. Uh-oh, do you see it? Yep, the top factors. Natural log of e squared minus 1 times e squared plus 1 over e squared minus 1. You can see that those cancel. Natural log of e squared plus 1. That's your final answer. What do you think about that? So I'll just give you 2 examples of definite integrals so that you can see how they write them a little bit differently. And then put my snowblower away. Lots of snow. Okay. Problem C. A for the day if you can guess what u is going to be in this problem. No, you can't. Here's why. You got to come up with a 3x, right? Or at least an x. Who cares about the constant? We'll figure out a way to deal with that. The fact is that x right there, if we take the derivative, du is equal to 2x dx, right? Well, that accounted for my x. Now you don't want a 2, you want a 3, so let's multiply by 3 halves. So 3 halves times du is equal to 3x dx. We're okay with that? All right, so we have 3 halves times the integral of 5 to the u du. The question is, do you recognize, you're going to start to ask this question a lot in calculus too. Do we know the antiderivative of 5 to the u? We do. We just wrote it down, didn't we? It's 5 to the u over natural log of 5, right? Isn't that the one we wrote down right here? If you have a number to a power, an exponential function, it's that function divided by the natural log of the base, which is the same as e to the x, because what's the natural log of e? 1. So you can see it just goes away. So in this situation, we have 3 halves times 5 to the u over what? Natural log of 5 plus c. So this is going to be 3 times 5 to the what power? What is u? X squared over 2 times the natural log of 5 is the same as the natural log of 25 plus what? No, you can't, because this is 3 to the 1, this is 5 to the x squared. They have different bases. If they had the same bases, then we could add the exponents. Order of operations require that we simplify the exponent before we multiply something else. Okay. A for the day. Why? Why natural log of x? Give me a better reason than it's in parentheses. That's the answer. Because when I take the derivative, what is the derivative? You get 1 over x dx. And as you can see, we get the x in the denominator. That's why we choose u to be natural log of x, because when you take the derivative, you come up with that x in the denominator. But I need a 4 in the denominator, so I should multiply by. A fourth du is equal to 1 over 4 dx. Whoop. Sorry about that. 4x dx. So I have 1/4 times the integral of what goes in the top. Anything in the bottom? No. Yeah, that's kind of cool. Antiderivative of u squared is u to the 3rd over 3 times 1/4 is u to the 3rd over 12 plus some constant. Remember what our u value is. Natural log of x to the 3rd power divided by 12 plus some constant. You all right, Tob? Because if you were to take the derivative, the constant would just go away. So therefore, this is, like, you could put a 2 there, and when you take the derivative, you would get when you take the derivative of this, let's say it was plus 2, you would get that. If you took the derivative of this plus 0, you'd get that. If you took the derivative of this plus 180 million, you'd get that. Okay. Here we go. Backside. No substitution for this one. What do you do? So why haven't we been able to do this problem before? I bet I've come up with this problem 3 times in your previous assignments and had to change it because it's like, shoot, we haven't been able to do this problem yet. It all hinges around this one idea. 2 over x we haven't been able to do before, have we? Because when you used to look at 2 over x, you used to write it as 2x to the negative 1. And what you would do is you're like, okay, let's increase that by 1 and then divide it by that exponent. So you get x to the 0 over 0. You're like, oh no, what do I do? Well, now we know that the antiderivative of 2 over x is simply 2 times the natural log of x, right? So we haven't been able to do it before. Now we can. Let's do it nice and quick. What's the antiderivative of 3x? X squared over 2 plus antiderivative 4? 4x minus, very good, 2 natural log of x. You could write it like that, or you could write it as natural log of x squared. Either way is fine. This one does require substitution. We haven't been able to do this problem before. Anybody want to guess what u is? Why isn't it sine? Okay, the derivative of sine is not going to give you 3. Very good. But how about this? Okay, even more so, the derivative of sine, does that give you a cosine in the numerator or a cosine in the denominator? Cosine in the top. And you want the derivative of cosine, that will give you a sine in the top. So that's really why we choose that u to be 3 plus the cosine of x. Which means that du is equal to, what's the derivative of cosine? Negative sine? Do you have a negative sine of x dx? Change the negative. Now I have a new integral. Put my negative out front. What goes in the top? Yeah, you've just got your 1, and on the bottom you have u. What's the antiderivative of 1 over u? Natural log of u. So you got negative natural log of very good. Now, if you, what could you do with this negative instead? No. So your other option, so I don't know how the book would write this. It would either write it like that, or it would write it like natural log of 1 over 3 plus the cosine of x, because you would take that inside to the negative 1 power. So it would all move to the denominator. No? Okay. Well, I'm fine with either answer here. On the front, I want your answer simplified, especially if it involves numbers, but I don't see the benefit. I think they would probably write the negative up front, but who knows? All right, last problem. Look at that. You're in 20 minutes to work. What? Oh. Very good. What's the derivative of the square root of x minus 2? Now, if du is 1 over 2 roots of x dx, that's almost like what I have there, except I need multiply by 1 over 2. So 1/2 du is equal to 1 over 4 roots of x dx. Now I have my appropriate substitution. I set up my integral. And this is what throws people in Calc 2 a loop, is that they don't remember all these pieces. Okay, so when you get to Calc 2, you know, you take Calc 1 over again, your friends in class are going to think you're the smartest person walking the face of the earth. No, it's just people are struggling to remember these pieces. You know, how do you take the antiderivative of that? That's what you want to be able to remember. Use my substitution. You end up getting e to the u to u. Well, that's really pretty simple, isn't it? I mean, it looks really bad, but really, this is pretty. Antiderivative e to the u is. And substitute your u back in. Square root of x minus 2 plus some constant. Oop! Yeah, no, that's right. I thought I had the minus. I thought I was going to have to distribute, but it's... Sure, yeah, over 2. That's fine. That's it. You like integration? You know how to do it. Because you're super smart. Alright, let's give you some assignments. See, small practice. You have all day, the rest of today and all day tomorrow work on it.